Start recording. Okay, so, all right, let me tell you, everybody, what's going on with this video. So I'm learning Scala because I have to use it for work. And so what I decided to do was port this Voxel engine that I wrote in C++ to Scala. And I'm doing that sort of as a learning tool, right? So, and then I decided, well, okay, I'll share it on YouTube. But the greatest thing happened. I have the absolute massive privilege of having my buddy Xcom with me on right now through Discord to talk about it. So
privilege.
Yeah, privilege. Yeah. The amount of legitimacy that your presence on this adds to this is just, incredible. So
I'm just a regular dude,
Yeah. Except, so your regular dude, except to the people who've seen your YouTube videos where you cracked Minecraft in like the most awesomest ways possible.
But that's like 30 people that's seen those videos.
But they're the 30 most important people. Okay. By the way, one thing this thing needs is a name. I'm calling it Voxel, which just sounds really stupid.
No, that's actually a great name. I like that.
I don't know. Let's see if maybe some people leave some comments in the on YouTube about that.
I like the name,
all right.
honestly.
Voxel. Okay, cool. So here's what I'm going to do. I'm going to kind of go through some of the code. We'll see how much time we have. I don't know. I'll try to see what we can do about half an hour. So I've got a little kind of an agenda of things to go through, but obviously XCOM is here to ask questions because, maybe I'll say something that like something that people don't get, and XCOM can help, ask the right questions. And okay, so now one of the weird things I had to do, I wanted to do this whole thing in Scala, but Scala does not support Java's static inheritance. So and so that made it a real pain to try to use LWJGL from Scala. And so what I decided to do was make a sort of like a shim layer in Java where I put all the lowest level stuff and then I build the game on top of that in Scala. Okay. And,
very creative solution, to be honest. And
I guess if you've ever looked inside of an application like Apache Spark, which most people haven't, but it's one of the most well-known applications written in Scala, it has a lot of Java code in it, and Java and Scala interoperate very, very well because they both target the JVM. So it's really not that weird to import Java code. There are a lot of things where the best solution in Scala is actually to use something that is imported from Java. So, and I do that in a few cases, like concurrent hash map, for example. So I figure I'll start with like the lowest level, and so what I've done is I've put mostly like the OpenGL stuff in here, right? So I have an example here is this rendering utilities class, where I have, here's this thing I render the crosshairs by calling this thing called render line. So I set up a shader, which I'll get into. I have an off heap buffer of the coordinates, a number of vertices, and then I need a vertex. What is this called? It's a buffer object and vertex arrays and buffers. Okay, so that I need for OpenGL. And these things get lazily created. So I can create this in any thread.
This section is the Java section of the
right.
code.
Exactly, yeah. So this is part of the Java section. And so I in order to draw the crosshairs in the middle of the screen, I'm actually using this function right here. And so it just like handles allocating stuff. And it only needs me to pass in a reference to the shader and like the points that it needs to draw, and then it'll draw it for me. And so the upper level that's written in Scala that's using this doesn't have to know about any of these things, and so I don't have to worry about figuring out, this one was introduced in GL 1.5 and this one was introduced in GL 2.0, and I could just do the static inheritance in Java and not have to worry about it. So so obviously it's a game, Voxel engine, and I need a window. So I have this. What I did was I created an abstraction for a window that is basically the interface that the rest of the engine uses to deal with a window. Okay, but this doesn't have any of the low-level implementation. It can handle things like, for example, there's a render loop. Okay, so the main game loop, you call into render loop and it iterates until it's supposed to exit. Okay, and what it's going to do is for each render pass, it's going to pull inputs from like the keyboard and mouse, and then it's going to send those to any input receiver. So anything can extend or implement the input receiver interface. Okay, and so this will send the I/O events to them, and then it will render all of the it'll call all of the render agents. So I have an interface for render agents. So when you set one up, you can create it. There's a destroy method. There's a way to query whether or not it's actually going to render anything. You can tell it, okay, it's time to render. And then also if the window resizes, there's a way to get a message. So in this window,
and these are being accessed from the Scala, or is it these are abstracted away? And
this is an abstraction written in Java, and then in Scala you can extend this, you can implement this interface with something that just provides these methods, and then it can be a rendering agent. So
see. Yeah. So anything that is the three main accessible the top layers can only access these three classes or interfaces.
Right. Yeah. So you can access anything, but the idea is that what I want to try to do is have all this Java code be the lower level, and then implement like the rest of the logic on top of it, the more abstract stuff, right? So conceivably, I could replace all the GL stuff with like Vulkan or Metal, and it shouldn't make too much of a difference. Right, and I also try to do minimal sharing in the other direction. So there are a couple of Scala classes that are used by the Java code, but for the most part, it's Java classes used by the Scala code, right? So, but it's not a perfect separation of layers. But you can think of this as kind of like a driver for the lower level stuff. Right. So here we have like render all. So basically these render agents, you can specify a priority, so they get iterated in the order of priority. So this way the crosshair gets drawn on top of the game 3D stuff. Okay, so basically I'm going to iterate over these rendering agents, and I'm going to find out which ones will render. And if none of them are going to render anything, then I can actually skip rendering the frame. Right. So one of the things that bugs me about a lot of 3D games is the
completely empty rendering. That's
it's rendering something, but nothing's going on. So it's using the GPU and using battery and energy to do nothing.
So you tab out, for example. That's
right.
Concept. Yeah.
Exactly. So in this case, like you can tell if something's not going to render anything, and if nobody's going to render anything at all, then it'll just bail out, and then it'll like wait for a frame. And then it'll try
That's
again.
An interesting concept. So you could basically make a headless version of the client if it's tabbed out, so that it doesn't hog your resources.
That's really exactly. Cool, yeah. And then if I do it right, then like any time that there might be something to draw, but like the game has had zero state change, then I can just say I'm not going to draw anything, and if literally nobody says I'm absolutely definitely going to render something, then I can just skip it. So and there's there's a priority order for that, and there's a priority order for processing the input event. So if the event is the idea here is, I don't think I implemented it correctly, but the idea here is that if something of higher priority consumes the input, then it's not sent to anybody else. So
that part doesn't make sense. So that if it's
okay,
So it means that if it's not finished processing the frame, it won't update the window.
Well, consider this. Okay, so you got the game, and the keys would move you around, right? But you popped up a chat, and now and the chat wants to take key presses, and what you want is the chat to take priority over the game. You don't want to be moving around when you hit a W in the chat, right?
Oh, that makes sense.
Right, and so the idea is that the chat will set itself as a higher priority, and when it's enabled, then when it gets a key input, it will return a value indicating that it has consumed the input, and therefore that input will not be passed on to any of the other input receivers.
That makes sense.
Yeah. So
that's interesting way.
Yeah. So that's kind of like the core of what's going on in this window interface. I mean, there's a bunch of other stuff like setting the field of view and setting a resize event is handled here. And so all of this stuff now the real implementation written in OpenGL, using OpenGL is therefore extends this abstract class and actually provides the actual implementation. So here I create a window and do a bunch of settings and all this kind of stuff. I'm kind of skimming through this because it's up on GitHub, so people can look at it. But basically, all this low-level stuff of handling key events and handling the window and whatnot is handled here.
You could basically ignore the parts if you're familiar with OpenGL in this section.
Right.
Just go to the parts.
Right.
That works out.
Yeah. So you want to use the window, and you want to tell it, okay, let's destroy the window. Consume the to get rid of the resources. Then you just call that on the interface. You don't need to really know what's going on underneath. That it's using this GLFW thing. Yeah. So next thing, I want this thing to work in multiple threads. So if let's say I want to assign a texture to something, I want to draw a block and there's a texture associated with the face, then what I've done is I've made this facility for managing a persistent library of all the textures. So what happens is you say, I want a texture. Go look me up a texture. And it's lazy in its implementation, because all it does is it registers the existence of the texture, but doesn't do anything texture related. It doesn't load the image. It doesn't load it into the GPU memory. It doesn't do any of that until you try to bind the texture. Okay. So, and the reason that I want to do that is because then you can create a texture in any thread, but it won't actually do anything OpenGL related except in the OpenGL thread. So, and so here, we have this main entry point. We'll look up a texture. We can look it up by name. So if the texture's name is wood, or whatever, then, it'll get ready to load that image. And so then when we go to bind it, right, it's going to find out that it hasn't allocated a texture ID yet. So it's going to go ahead and load the texture. That gets it into memory, and then it binds it to, does some settings on the texture and gets it ready to be actually used when you're going to do some drawing. And so now we can support destruction of textures, but the main idea is that you've got this library of textures, and when the first time you reference a texture, it gets loaded and it persists, and you always refer to it by name. You never double load a texture or anything like that. I do something similar with shaders. Okay. So, when I want to create a shader, I'm basically just going to, set the code, right? So I can set from a string or from a file, I can set the fragment and vertex code, and it doesn't do anything. So I can set that in any thread I want. But when in the GL thread, I go to bind the shader so I can actually use it to draw something, then at that time it will go and try to compile the shader. So, I suppose that could result in exceptions being thrown later, but then what you'd prefer. But basically, if it's already done that work, then doesn't, then it just doesn't do anything. And then, and if it hasn't set up the shader yet, then it calls this method to do all this setup, and just basically loads and compiles the shaders and gets them loaded into the graphics card.
Seems like a very good setup. So unless you're very familiar with OpenGL, I would assume that most people would probably use the default shaders, and everything else will be handled by the default shaders, so that you basically have to deal with the complexer nature of all this lower layer stuff.
Yeah, I mean, the thing is with GL, I don't remember which version or later, like 2 or 3 or later, I can't remember which one, actually providing a shader program became compulsory. So even if it's the most trivial thing, where like the fragment color is a constant, it's just white. I just want to draw white pixels, like nothing but white, right? It doesn't matter. You still have to have a shader program that does nothing but return white, right? So in fact, I could probably pull that up real quick. So here's the shader programs for the crosshair, and so for the vertex code, like all it does is it takes the position that I'm passing in. So basically, I have a line, and really, I think it's turned into some triangles behind the scenes. But basically, you have a vertex of what it's going to draw, and I just take that vertex that's a 3 entry XYZ and turn it into a 4 vector, because that's what OpenGL or the graphics in card wants. And that's it. I'm just saying, all right, well, the vector, I'm just passing the vector through unmodified. And then for the fragment shader, I'm saying, okay, check it out. It's just going to be white with no transparency. And that's it. Like this is, if you want to draw the simplest thing in OpenGL, you have to have a shader like that. So
that makes sense.
Yeah. So most of the shaders I'm going to load from disk.
So you have to have a little bit of an understanding of what you're fiddling around with the shaders. Even if you're, that makes sense.
I gotta say something about the hours that I've spent trying to debug things where I run the program and there's like literally nothing drawn on the screen, and I can't figure out why, and there are no errors being thrown by OpenGL and like OpenGL's native coordinate system is left-handed, but when you do a projection, then it becomes right-handed for some reason by convention. Oof. And that confused the heck out of me. There's this weird quirks of I think like DirectX uses a consistent, like the handedness of the coordinate system is the same throughout, and so that's something they did a little better. So it talked about shaders, right? So again, it doesn't get compiled until we try to actually bind it. And so that doesn't happen until we're actually going to use the shader. And then, so then the next thing we could talk about is a face, right? So this is a voxel engine, and I'm kind of like cloning Minecraft here. Oh, so one of the things I should mention is, okay, why are you making yet another clone of Minecraft, right? Like, that's boring. There's like a million clones of Minecraft. And I thought about that. And the thing is, all the clones that I've seen use a pre-existing game engine, like Unity or one of these things. And but I haven't seen anybody do it completely from the ground up, like do all their OpenGL from scratch. So I mean, maybe that'll be a little bit more. Yeah, it is. But I mean, Minecraft is built that way, right? So I'm gonna try to. I don't actually know how Minecraft does any of this. And I don't want to know, because like I don't want to get accused of copying Minecraft.
Oh, I see. But it's pretty much like White Room. Like I don't. I've seen over it. Like, it doesn't seem like it's old. Although there might be similarities in some areas, it doesn't seem to be like any form of copying.
Right. Well, I mean, one of the things is, since I'm doing a lot of it in Scala, it's obviously it's not just a copy and paste from like decompiled code, but But I'm trying to come up with my own ways of doing these things anyway. Also, if I'm porting anything, it's my own code. I'm plagiarizing myself because I have this C++ implementation that I did that's also up on GitHub, right? And basically, there's some of these things where I'm trying to rethink it, trying to do it in a little better way than what I did, and there are other things where I'm just like, you know what? I'm just blindly translating the code from because I'm tired or want to get through it or whatever, blindly translating it from C++. So I do because it worked. It's just that I had people tell me that it'd be much more interesting to them if the game were written in Java because it would be more hackable. And I'm like, but I'm thinking I'm going to make this I'm trying to build this thing in a way where there's like layers of APIs. Like I want it to be dead trivial to make a block that does whatever you want, that receives events, that can make itself appear however you want. Like it's like, imagine that if Minecraft were built with with like Forge or Fabric built into it from the beginning, right? Where it was, where adding mods was like part of its design, right? I
think Mojang mentioned it's been something that they called an API they wanted to add. So that's pretty much what this is. Pretty much at the beginning, an API on top of the main engine.
They added it to. They added one to Bedrock Edition, right? Because the C++ code isn't so nicely hackable, right?
That makes sense, yeah.
Yeah, but the fact is, especially since they released the symbols and they're really supportive of people decompiling the code, right? It's like very hands off. It's like, we're not going to give you the code, but if you decompile it and then you figure out how you want to hack the game, that's great. In fact, how many of their current engineers are former modders, right? A lot of them, right? Like Sarge wrote the was that first decompiler? Was it called?
It was a long time ago. I don't remember.
Yeah. But I mean, that's why they hired him because he knew the game already, and so this is so they're really supportive of that. But what I think is the case is that the communities that have built these modding APIs, that's what they focus on. So they're doing a really good job, or comparatively speaking, of implementing these modding APIs, and so Mojang doesn't have to, distract themselves with supporting this, right? It's a support burden that they don't really need to do, right? As long as they share enough information with the modding community so the modding community can keep up.
That's true.
Then it's just handled and everybody's happy because the modding community has control and there isn't a lot of complaining they'll complain about Forge project doing things the way they don't like, but they were not complaining about Mojang not doing things the way they don't like, at least in that area, right?
That's
so
true.
It's a good way to distance themselves from that. Anyway, so now it's a voxel engine. Most things are cubes, not all of them, right? And cubes have faces. Yeah. So I have an interface classes for faces. Okay, and so you do things like get add a vertex or fetch the vertices. Like here, give me the vertices into add them to this float buffer, or how many vertices are there? That kind of thing. And so I have implemented triangles and quads. And like the difference between the triangles and the quads is like there's 4 points, but you need 2 triangles. So we reuse the coordinates. So we spit out 6 coordinates for a quad, but we only actually store 4 in the quad.
It seems like making a square. That makes sense.
Yeah. And then and also like the way you compute a normal is a little different because you got to figure out which 3 of the 4 to use to compute the normal to the surface. Then I have a no face, which is rather than having like a null for something that's missing, if I accidentally leave a no face in somewhere. It just like returns nothing, does nothing, doesn't contribute any points, and doesn't crash the game, right? So whenever I'm filling an empty array of faces, I put no faces in the empty slots, and then nothing bad happens. So then a mesh is an array of faces. By default, you're going to have 6, but you can have more. Like if you had a stair, right? That'd have more than 4 faces. But or 6 faces. But it's smart about handling cubes. So one of the really important things to do in a system like this is you've got all these cubes that are adjacent, and so they have faces that are against each other. I get a cube at position 0, I get a cube at position 1, and the faces that are between them are not visible. And so what you want to do is make them not visible. And Minecraft does this, right? I don't know what exactly its implementation is.
I think it's based on level part of the OpenGL. It might be using that part.
I don't know. I think you'd have to. I mean, OpenGL doesn't know about cubes, right? So something in the game engine is figuring out. Well, these two faces are on top of each other. Therefore, we'll just turn them off. Okay, and so for your 6 canonical, Cartesian faces, this thing is smart enough to know that which ones are solid and which ones are not solid. Something not solid sense. Might be solid.
Makes sense now. So if it's a multi-block system, which faces it should omit? That makes sense.
Right. Exactly.
Yeah, that's the logic.
Yeah. So I'll give a little sneak preview. Hope I didn't break it. So here, this is my wood texture, by the way. I know it looks a lot like a Minecraft wood texture, but I made it myself. Okay. And so if you didn't delete the faces, then you went inside of this, then you'd see the other faces. But in fact, it all just disappears because, all the joining faces between blocks have been determined that they wouldn't be visible anyway. And so, Minecraft relies on this heavily in spectator mode, right? You can see through the world. It's because they've omitted all of the invisible faces that you couldn't see anyway. And what's important about this is for performance. Like there's so much less that the GPU has to draw, orders of magnitude less. Like now it's only just drawing the outside. And for that matter, I've got backface culling enabled, right? So these faces aren't being drawn when they're facing away from the camera. So it's literally just now there's 3 faces are being drawn. That's it.
Yeah, that's.
I
remember that this being a big problem in Minecraft as well. Just to be able to figure out the faces was like a big optimization, but it also hugs a lot of the CPU.
Yeah.
I remember.
Yeah. So what I've done is I've thrown all of the work of figuring out adjacent faces and hiding them into its own thread. So we can get into that. Yeah. So it's kind of in the background, kind of lazy updating that. So you place a block in the world. It doesn't necessarily delete the faces from the meshes right away. Right. So the first 6 faces of a mesh are in a particular order. So I have this class that keeps track of this stuff. So face 0 is down, is the bottom, right? Face 1 is the top. And so now when now you can do a little bit manipulation. If you want to know what's the opposite face of something, you just XOR it with 1. So XOR north with 1 and you get south, or vice versa. So this way I can see that the north face of a block is up against the south face of the adjoining block. And then I just delete both of those 2 faces. It's not really delete them. I mean, I marked them as not visible. And then when the renderer goes and iterates through the chunks, it just isn't given any of those faces. Right. And so now you can have obviously more than 6, and then it just, all of those will get rendered by default. So if I had something like a stair, okay, then I could make the back of the stair solid and the bottom of the stair solid. They could get removed, but then the side isn't. The sides and the top and and so those would be faces 6 through whatever, and would always be rendered, right? So and I checked this in Minecraft. What I did was I placed a fence underground, a fence post, and then I went in spectator mode and looked underground, and I saw that none of the blocks, none of the surface of the world or anything is being rendered, because I'm looking at the back faces of everything, and everything is invisible, and they're all solid blocks except the fence, which doesn't have any solid faces, and therefore all of it's visible. And then I tried with a piston that was extended, and it deleted the back of the piston, but none of the rest of it. So yeah, so I'm
the problem of smaller blocks that are less than block. Yeah, that
exactly
cause a lot of problems.
Yeah, like chests causing lag because or low frame rate because they can't be removed, which is why they had to do hacks like not display chests if you're a certain distance away from them. Right.
Oh, that's true.
Yeah. And which is I'm may find that I need to do something like that eventually. So right. So what do I want to talk about next? So you can get so you have triangles that are parts of faces, but here we're looking at a mesh, which is a list of triangles. So one of the things that this method here is doing is it's finding out, because I want to know how much space do I need in order to store the vertices for the things that I want to draw. So the vertices, the texture coordinates and the normals. And so we can calculate these things and then find out how much space we need, and then we can go and get them all. I don't know if this is an efficient way of doing it. Maybe it'd be smarter to have a resizable container. I don't know. But the way it works right now is I go and find out how much of the chunk is how much space is needed to store all these numbers to describe the chunk that I need to send to OpenGL. And then I go and fetch the data. So here I'm passing in this float buffer, and I'm gonna and when I call down to the faces, it's gonna just append these coordinates to it. And here's an interesting thing to point out. So I have a position of the thing that I'm drawing, okay, in the world, which is it's a double precision floating point, but OpenGL wants single precision floating point. And so one of the things that that people often discover when they're doing a game in OpenGL and using single precision floating point is when they get too far from the origin. That's true, yeah. The low precision of floating point bites them. And so I went ahead and dealt with it in advance. So relative to the camera, I'm computing a view center that's like the 0. I have a new origin. The new origin is a block position close to the camera. And so I have to pass this around because I'm rendering everything relative to that artificial origin. And this way, everything you can see is using relatively low values in floating point.
This is probably something that was dealt in the earlier versions. There was world jittering. Yeah, there's this far-length or rusts.
Yep. yeah. Right. Well, I mean, really early versions of Minecraft. Early versions of Minecraft only had a few hundred by a few hundred blocks, and they didn't have to worry about that. But once the world went infinite, this is something they definitely had to deal with, right? And then of course, then people do videos where they get to the extremes of double precision floating point. Ed Example's got a video where he talks about that. He shows some jittering going on that's an artifact of double precision floating point. And then what's really funny is if you turn on the captions, he mentions me, and I think he mentions you and Earth Computer, but you only know about that if you got the caption turned on. Yeah, exactly. If you've got a hearing problem like I do, then I have a mild crowd deafness thing, so I'm always got the captions on. Anyway, So then I've got a mesh renderer. Okay, and that's job is to display meshes. Okay, so like the thing that the main entry point that we care about here is load meshes. So I'm going to provide an array of meshes and the corresponding array of block positions of those meshes. So these would be blocks that I want to draw, like the visual representation of a block. These are the positions of the blocks. These are which faces are visible. So I do the calculation in the chunks of which faces are visible, and then I pass that in. And then I've got how many of each of these things, and I have my camera view center. And so then I'm going to go through and I'm going to find out, all right, how many vertices do I have? How many vertex floats for triangles? How many texture? How many floating point values I need? And then I reserve space for those in these off heap buffers that I need in order to efficiently pass this data to LWJGL, and then I go through and actually fill those buffers and then flip them so that the position is starting at 0, so that when I go to load it. So now once this is called, this thing knows that and I can do this from any thread, by the way. I can load these meshes from any thread because it doesn't do any OpenGL. So there's a thread that actually loads what's going to be drawn, but then there's the OpenGL thread where it actually does the rendering. Okay, and like even the GL buffer array here is lazily allocating the array on the GPU. It doesn't happen until we try to use it. So when we want to draw, okay. The first thing that we do is we load the OpenGL buffers, which involves actually like telling the GL array to load this data, right? And this is the point at which some of these things weren't real yet, and they actually get allocated. All right. So I showed you rendering utils, render. Yeah. So this is vaguely interesting. Render data buffer. It's basically a float buffer with a little bit of help, for like reserving space. And then there's the GL array buffer, which is so you got to store. You have to put the vertex data in some CPU memory, right? Main memory. And then you've got to copy that into the GPU memory. And so the GL array buffer is what reserves the space in the GPU and copies that data over there.
It's just, this is probably related to the low-level OpenGL stuff. So I guess...
Right.
Yeah.
Exactly. So here we have, we're basically saying here, load that vertex array, load this buffer into the GPU. I feel like I'm forgetting something. Like how many? Oh no, never mind. Okay, so yeah, I mean this is the thing that does the work of actually copying the data from host memory into graphics memory.
And, low level, the low level stuff. Right. And this is a bit difficult to follow which part of it would be like abstracted away and not to be looked at directly by the top user.
Well, yeah, so we can find usages of this, right? And actually so that's used by this, and then we can find usage. This is the mesh renderer, right? And then we can find usages of that, and here we go, right? So here we have a draw. This is part of one of the draw methods for drawing translucent blocks, and it loads it basically for each translucent block. It does a little setup, like sets the view matrix and in the shader, and tells it to load the OpenGL buffers with the data representing those blocks, and then draws them. So anyway, so the point is that these things this buffer doesn't exist until you ask for it, and this load it's like, oh, I don't have a VBO yet because I shouldn't expect to have one.
So everything is basically lazily constructed. Yeah, that's
exactly.
very efficient. Yeah.
Well, it's really important for threading. I'm pretty sure that you can't do OpenGL in anything other than the main thread.
Yeah, it has to be on the deep OpenGL thread, I guess. Yeah.
Right. So, but I still wanted to be able to do all kinds of calculations and setup in another thread. So, like, data gets created, but it doesn't get loaded into the GPU. I don't know OpenGL calls are made except.
I see. So
you
shuffle the data between different threads just to get it on thread. Yeah, that's pretty creative.
Mm-hmm.
It's really interesting and creative.
Yeah. So, all right. So I showed you render agent. Talked about that. Input receiver. You can get different kind of input events. Here. So like here's a different kinds of input events, key and button press and stuff like that.
Yeah.
And then there's another thing that I did is if you want to get rid of, there's certain resources that are graphics resources that can only be destroyed on the graphics thread. But I want to schedule its destruction on any arbitrary thread. So I have this disposer service that takes care of it. So I did this cheat. See, I mean, I'm designing this thing, so I'm like abusing my own stuff. Okay, but what I didn't want to do was create another kind of interface for something that gets called from the render loop. Okay, so for this disposer, what I did was I made it a extend the render agent. So for in Scala, there's no difference between extend and implement for an interface. You just use the word extend. So I made it a render agent, and basically I don't want it to think it's going to render anything. So I'm going to return false from will render. So I don't want it to like force things to get drawn. But so in the will render method, I call this method to actually drain the disposal. So there's arrays of anything that implements disposable, and also lists of anything that implements disposable. And so then they get destroyed, but only as in the main loop.
Cheaty way to sneak dispose onto the rendering.
Yeah. But I mean, it's funny because I'm the one who designed it, so I'm only cheating against my own design, right? But it was, but it's like, hey, well, so maybe it's clever, right? Maybe it's not cheating. Yeah. It's just I didn't have to add an extra interface, right?
Exactly. It's still like you're just disposing of content, and it's like.
So then we can get it, like, and look in this game into the game here. Let me close that out, and so I'm not really sure what order to look things in. So I just kind of decided to go in kind of an arbitrary order. For one thing that you need in the world is a camera. Okay, so I have a camera model that knows about the window, so it can talk to.
It might be like actually you've pretty much gone over all the Java section of the code.
Yes. Yeah, pretty much.
That would be actually a great part to split the video into.
Okay. So should we? You want to like record this separately on another day?
Yeah, that would be.
Okay. Okay. You gotta. It's late in Sweden.
Yeah, it's super late.
Cool. Okay. Cool. So now the next question is: am I going to be lazy enough to not cut out this portion of the discussion?
No,
or am I just going to leave it in?
Part of the video. But it's just that I think that the better part is like you have to get a grasp of lower layers, which is Java section, and then the Scala is the layers on top. I guess that it'd be good. Because in my opinion, it's like the lower layers are really interesting for Java developers to be able to take a look at it. And the Scala layer, it might not be super interesting for the Java developers. But the part which is actually super interesting is that you actually managed to merge those two languages and no problems at all to getting it working.
The biggest problems are actually IntelliJ, because IntelliJ has, especially, I was trying to use Scala 3, and IntelliJ has all kinds of problems with that. So I'm using Scala 2.13.10 or something, which is good enough. Yeah, but I mean, in terms of the JVM, once it's bytecode, and it doesn't matter anymore.
True.
But it is kind of a cool thing about IntelliJ that, with the plugin, you have to load a plugin to support Scala. And it's kind of buggy. But when it's working, it does a really good job of figuring out this code that in Scala is referring to that code in Java, and it can tell if you've misspelled the method or you're not passing the right parameters or any of that, and we'll do the error highlighting and everything, and it'll do it in both ways. And also, if you copy Java code and you paste it into a Scala class file, it will ask you if you want to convert it, and it will try to convert it, and it usually does a decent job. It's too bad I can't get it to do that with C++. That'd be great, but the style, it'd be extremely difficult because the approach that I had to take is completely different.
But could it be possible that someone could go the other way around if they want to just see a complete Java project?
What do you?
Just take the Scala and convert it to Java.
Yeah, well, it's just the Scala plugin for IntelliJ doesn't support conversion the other way.
Yeah. I guess that's a problem that's going to be funny for people to. You have to learn Scala. You just have to.
Yeah. Well, I'm doing this for me and to learn. I'm still coding the Scala code like an object-oriented programmer. I'm doing, I'm adding a little more and more functional stuff in there, but I still think like a C++ or Java programmer, and so there's, the closest I get is I'm like, ooh, I can use map instead of a loop to convert this to that, there are some things that took a lot of lines of code in C++ that would take a lot of lines of code in Java that take one line of code in Scala.
So that's I guess the functionality of being a functional language. Yeah, that gives you so much more freedom in those functional sex.
By the way, real quick before we go, I asked ChatGPT to give me code to do Perlin noise, and this is the code it gave me. It absolutely does not work.
Oh yeah, I've heard that ChatGPT is terrible. It's the worst programmer ever.
And I don't know how.
It tries to trick you every time. Like you think it works, but no.
Evidently, it does okay a lot of times, but I have no idea what's going on in here. I don't understand how Perlin noise is supposed to be like computed. So let's just say hypothetically that it was slightly wrong. I wouldn't know how to fix it. I don't. Because I don't know.
I don't chat GPT. That's just. I think they've designed it to trick programmers to, become like not dependent on it or something along. I
don't know.
Never trust. Trust.
It's a language model. It can have conversations. So I can have conversations about things like linguistics or computer architecture. Obviously, I've got a PhD in computer architecture, so I've asked it questions that are like deep stuff in computer architecture. And like, for example, it got instruction dispatch correct, but it didn't understand the distinction between that and issue. Its description of issue sounded similar to its description of dispatch.
That's
I could explain it to you. Well, maybe you could explain it in another video.
Yeah.
Because but I mean, anyway. So I was just like screwing around. I didn't think it was going to work, but I figured, hey, what the heck? Can you give me some code that'll compute Perlin noise? It gave me code.
It sometimes works though, apparently.
Yeah, but I also had to fix it. Like it thought that it could modify. It tried to modify the value x inside the function, and you can't do that. Maybe you can do that if you say var here. I don't know if that's like legal. Maybe it is. I don't know. So I'm still learning the language, which is one of the purposes here. Okay, cool. I want to thank XCOM very much for
I'll be back
helping me out here, and being willing to. But I know we got to do part 2. Maybe we can do that tomorrow. That'd be awesome.
You know that part 2. Oh yeah, the part 2s. I will never make part 2s.
You don't make part 2s?
Yeah, I might be like a ghost appearance on this. Just kidding. I'm gonna be part 2.
Maybe I have to get somebody else to do part 2. Maybe I can get Earth Computer. Or that would be Myron.
Cool. Then you have to all the first video all over again.
Well, no, I have to make them watch the first video, and then I'm like, okay, now I have another guest on my show. So have you ever watched Star Talk with Neil deGrasse Tyson?
That's something that I've noticed. No.
Okay. Well, the one thing that I noticed is that his guest hosts are like comedians. I'm like, I guess that helps for like, it's like the Doctor's companion in Doctor Who. It's somebody whose existence is there to like make the show more accessible to their average audience. But I don't want that. I want people who understand what I'm talking about.
Yeah,
I want my guest host to be smarter than me.
I think that's going to be difficult.
Not if I manage to get Myron on or Ragu.
Like, programming wise, I don't think there's many people that can beat you. Maybe in maths, but programming wise, I don't think there's many.
No. Like I work for Amazon, and I got used to being like I could outcode most computer science professors except a few that I knew. And I mean, I had a lot of industry experience, right? So, and that helped. And I could, working at a small company at AZO, I could, I was legendary, and I had all this, stuff that I developed. I go to work for Amazon, and I'm like, I am not smarter than these people, like at all. Like there's people who are so much like they make me feel dumb. Just how good these people are.
That's impressive.
Like Amazon does a good job of hiring really smart people. It's too bad they're doing these layoffs.
Hopefully you're not doxing yourself in the video.
Well, I mean, no, I've talked to people about. I mean, I work for Amazon. I'm not telling them like where.
But then your name is right there in the video.
I don't know. I mean, I work for Amazon and I'm saying good things about them, right? So it shouldn't be a problem. Yeah. I mean, people know my real name. They know how to find my doctoral thesis, Yeah,
that makes sense. Like you don't have to be that people you can be easily figured out. Yeah.
One of those kids, what was his name? Anyway, he found out my home address. I'm like, why are you looking at property records to find out what is wrong with you?
On the internet, anonymity can go one way and the other way.
Yeah. Anyway, okay. Well, thank you again. I'm gonna end this video. I'm gonna hit stop recording, and I'm gonna go ahead and upload. So, and I'll have to remember to put a link to the project in the description.
Yeah. So bye from me.
All right. Take care. Thank you so much. I will catch you tomorrow.
Fun.
Bye. Yeah.
Thanks for joining.
Thanks for joining me.